Imagine a hot cup of coffee. Take the hot mug of coffee in your hand and you will feel your hand getting warmer while the mug gets cooler. However, you cannot make the reverse happen.
This is because heat always flows spontaneously from a hotter object to a cooler object.
This is a thermal gun. It measures the heat signature of any given object. Let's look at a few objects that are part of our daily lives. A glass of cold water, a cell phone, and a laptop. Each of these gives out its own unique heat signature based on the movement of energy and flow of temperature therein. Heat is a form of energy that gets transformed through induction, conduction, and convection. Whenever a substance is exposed to heat, the molecules inside it acquire kinetic energy, which leads to the increase in the temperature of that system, just like when you mix hot water with cold water in a glass.
The same applies to any building, especially in a tropical country like India, where there is ample sunshine.
Sun's rays can be divided into three components. One is called ultraviolet rays, then there's a visible spectrum, and there are infrared rays. Infrared rays are what is responsible for delivering heat to Earth. So if you can, at any level, get a mechanism which is efficient enough to reflect these back, a lot better, you will get a far cooler surface.
With temperatures touching 50 degrees Celsius in some parts of the country, the scorching heat of the sun literally penetrates into our living spaces.
When the building material absorbs IR rays, the heat in the system increases. Because of the increase in heat in the system, the temperature of the material increases, which is transferred by absorption to the building, and internally you start feeling very warm.
There was a need and a market to create new products that would provide relief from nature's harsh elements and were inexpensive, effective, and available on a mass basis. Paint was one such area. Guided by innovation, scientists initiated research into surface modification technologies that could make the world a cooler place. Their goal was to create a cost-effective and eco-friendly paint that could make buildings cooler.
When we started working on cool paints, the principle that we started on was actually insulation. So we started working on what typically gets used in these kind of things like ceramic beads, or different kinds of insulating beads, put inside the paint film. We actually figured that the paint film was too thin to deliver any level of insulation.
After the application of paint on a wall, upon drying it forms a thin film known as dry film thickness. For the paint to employ the mechanism of insulation, a minimum level of DFT was required. This was not achievable through conventional paints as the DFT was too thin. It seemed like the project had encountered an insurmountable obstacle. Searching for a viable alternative, the team of researchers returned to basics. They studied the components of solar light and the different ways in which materials and pigments used in the manufacturing of paints reacted to them. While the color white best reflects infrared radiation, black absorbs it. This measure of reflectivity is known as the solar reflective index. Through a proprietary process, they created a mechanism that helped them to achieve a level of SRI higher than that of conventional paints, regardless of the pigment color. This ensured that maximum heat-causing infrared radiation was reflected back, lending paints their cooling property and significantly reducing the temperature within interiors of buildings. The collective result of arduous research by labs at AkzoNobel in the United Kingdom, Malaysia, and India was a revolutionary technology called SunReflect. This innovative paint had a unique quality of keeping buildings up to 5 degrees cooler. It seemed like scientists had found the answer.
So usually people either prefer aesthetics or they prefer functionality and they make a choice between them. We have studied both the propositions and we have come up with Weathershield Sun Reflect, which gives you the normal functionality, which is seepage resistance, heat resistance, weathering resistance, plus it gives you a 5-degree lower temperature within the interiors.
Could this paint really bring down the temperature inside buildings by 5 degrees? Scientists needed empirical evidence to support their claim.
We selected Center of Energy Studies and Research to test this paint out and see the kind of sun reflectance that this paint was offering and how that sun reflectance is actually better than conventional paint. We also got Ernst & Young, an independent auditor, a very well-respected auditor from the industry, to check and audit our process, okay, or our own testing methods.
Tata Power got this sun reflect paint tested. The pilot project in one of its location building called SunNet, and the results were phenomenally good, and there was a reduction in the temperature of around 5 degrees centigrade, and the impact on the load factor came to around 10% in reduction of load.
The final test of the product would be to successfully meet consumers' ever-increasing demand for aesthetics and durability. Today, Cool paints are being widely used for their path-breaking technology across the country.
One of the many construction projects that have adopted this technology is built in the heart of the Millennium City, Gurgaon. This is the Aralias, one of India's most luxurious residential spaces. All the buildings within this complex have been coated with cool paint, and the benefits are being experienced by both the developer and the residents alike.
At Aralia, we have used sun reflective paint. It's a better version of any paint. It gives a very good look to the building, but inside also we can feel that there is a difference in the total temperature.
Built on the philosophy of being eco-friendly from all angles, this sprawling complex redefines modern extravagance. Composite wood, ash clay bricks, and other recyclable materials have been used to construct this iconic housing society. Robin and Shelley Bartholomew have been living in the Aralias for the past 2 years.
We lived in the earlier townhouse on 2 levels. If we had to go and visit my mother, who was at the lower level, we used to run down because the gaps between the rooms would be air conditioned, but the corridors would be really, really hot. So the difference is fantastic. It was like living in an oven. I can't even tell you how different the 2 places were. The first place was really, really hot, very hot.
Cool paints have made their presence felt amongst numerous families across the nation. Their lifestyles have now become eco-friendly and comfortable. The Aralias by DLF is just one of the many success stories of this revolutionary, eco-friendly technology.